hopefully this is interesting. I could sense from some of the talks it'll be a bit of a change of pace than some of the talks that have come before. I think I was prompted to talk about kind of a half theme of one of the blog posts I wrote about sycophancy and try to expand on it. There's definitely some overlap with things I'm trying to reason through that I spoke about at AI Engineer World Fair, but largely a different through line. But mostly it's just about modeling and what's happening today at that low level of the AI space. So for the state of affairs, everybody knows that pretty much everyone has released a reasoning model now. These things like inference time scaling, and most of the interesting questions at my level, and probably when you're trying to figure out where these are going to go, is things like, what are we getting out of them besides high benchmarks? Where are people going to take training for them? Now that reasoning and inference time scaling is a thing, like how do we think about different types of training data we need for these multi-model systems and agents that people are talking about today? And it's just a extremely different approach and roadmap than what was on the agenda if a AI modeling team were going to talk about a year ago today, like what do we want to add to our model in the next year? Most of the things that we're talking about now were not on the roadmap of any of these organizations, and that's why all these rumors about Q-Star and all this stuff attracted so much attention. So to start with anecdotes, I really see reasoning as unlocking new ways that I interact with language models on a regular basis. I've been using this example for a few talks, which is me asking O3, I can read it, is like, can you find me the GIF of a motorboat over-optimizing a game that was used by RL researchers for a long time? I've used this GIF in a lot of talks, but I always forget the name, and this is the famous GIF here. And Coast Runners is the game name, which I tend to forget. And like O3 just gives you a link to download the GIF directly, which is just taking where this is going to go. It's going to be like I ask an academic question and then it finds the paragraph in the paper that I was looking for. And that mode of interaction is so unbelievably valuable. I was sitting in the back trying to find what paper came up with the definition of tool use. I think there's a couple 2022 references. If you're interested after, you can find me because I don't remember them off the top of my head. But these are things that AI is letting me do, and it's much more fun and engaging than sifting through Google. And the forms of the models, so this previous one was just O3 natively, whatever system prompt ChatGPT has. But the form of these interactions are also changing substantially with deep research that we've heard alluded to and referenced. And then Claude Code, which is one of the more compelling and nerdy and very interesting ones. I used it to help build some of the back end for this RLHF book that I've been writing in a website. And these things like just spinning up side projects are so easy right now. And then also Codex, which these types of autonomous coding agents where there's not the interactivity of Claude Code is obviously the frontier that it is going. But if you try to use something like this, it's like, okay, it works for certain verticals and certain engineers. But for the stuff I do, is like, okay, this is not there yet. It doesn't have the internet access is a little weird. It has to build these complex images, installing PyTorch. It's like, okay, we don't want that yet for me, but it's coming really soon. And at the bottom of this is like this foundation where the reasoning models have just unlocked these incredible benchmark scores, and I break these down in a framework I'll come back to later as what I call a skill. And it's just fundamentally reasoning models can do different things with tokens that let them accomplish much harder tasks. So if you look at GPT-4o, which was OpenAI's model going into this, there was a variety of what we're seeing as kind of frontier AI evaluations where it's on the spectrum of the models get effectively 0, which is truly at the frontier, to somewhere to 50 to 60 is labs have figured out how to hill climb on this, but they're not all the way there yet. And when they transition from GPT-4o to O1, which if you believe Dylan Patel of Semi-Analysis is the same base model with different post-training, you get a jump like this. And then when OpenAI scales reinforcement learning still on this base model, they get a jump like this. And the rumors are that they're now going to use a different base model and kind of accumulate these gains in another rapid fashion. And these benchmark scores are not free. It's a lot of hard work that gets there, but it's just a totally different landscape where things like AIM and GPQA, which is this kind of science, technology, reasoning questions, are effectively solved. And this is like the use cases I was describing, where it's like O3 can kind of just do this. And a lot harder things we'll see keep coming, which might unlock some of these kind of use factors I'm mentioning as interesting, but not there yet. And we'll see this kind of list grow over time, but it's really not like the only thing that we're experiencing on the ground, because skills are like only one part of this, and there's a lot of this kind of arts and crafts of how do you actually have a good model that people like to use. And a lot of this talk is going to be talking about ways that can go right and wrong, and generally just my reflections as someone who trains these models on like why we get exposed to this. So there's a lot of online discourse about like models that go too far on training on benchmarks. This is an old tweet from 5 from Microsoft. I don't want to throw them under their bus because they've also like 5.4 is like a really good model by now. So like a lot of these people get these reputation for things that are maybe like a one-off model incident, which emerges from a complexity of org structure, weirdness, and individual incentives. And I think like Meta's really in this right now, and that doesn't mean their future models will be subject to this. But it is definitely a phenomenon that could happen where it's like a lot of low-level decisions result in the final product that is just not what you wanted, even though it seems like along the way you're doing everything right. And just kind of climbing these benchmark scores, which is linked to this thing that I was saying with skills, is not the only way forward. And especially with reasoning models, there's kind of another way we've seen this, which is Claude 3.7, where people love to gripe about this supposed upgrade to Claude, would love to just like fake its way through unit tests. And if you're looking at reasoning training, a lot of the technical implementation for code is you have the model generate code, and you check if you pass unit tests. And what people are seeing is that Claude essentially does everything and then modifies the code so that the test passes. And this is like a side effect of, at the training time, our reward function is just too simple. It's like we're rewarding the model for getting unit tests right, which might be disconnected from the overall theme. And like, there's just so many ways that this can actually come up. And it's like this RLVR thing, reinforced learning with verifiable rewards, let us climb these skill charts crazily, and both on public and private benchmarks. So I think a lot of the labs have benchmarks internally that are much more specific to things. And even those you could kind of fake yourself on. And like, there's examples of OpenAI and Gemini doing the same thing. And a lot of recent model releases have this sort of like, ooh, the coding is a little off energy. But I think a lot of it comes to this, which is just bypassing a unit test. And another really interesting one that doesn't quite have the same interference with the utility of it is like this Translose blog post and other communications when O3 was announced, where O3 will do this thing where you ask it a question and it'll say its reasoning for why it's true is some action in the world that it can't actually take due to its sandboxing. So this is O3 saying that it measured it on its MacBook Pro that it has, even though it's just running in the data center without access to it. I think this is a good example because things will come up like this that have actual physical meaning, but even if we could see it in such innocuous ways, it's just that this like, we're pushing so hard on these skills and the measurable things that a lot of the unmeasurable becomes a second priority goal. And this is the sort of thing where it's a teammate at a company will be like, we're so much better at coding, search, math, everything. And it's like, oh, the leadership needs to get the model out for competitive reasons. And then some of the things is like, okay, we do this messy process of making the model much more robust and getting rid of these oddities in the training data and stuff like this, and you kind of do this later on. So it's kind of this back and forth when the pace of progress is so high that you have to make hard decisions on what you prioritize. And a lot of times, these weird model releases are actually just technical bottlenecks. I think this is one of my most entertaining model releases of the year is when OpenAI released GPT 4.5, and they released this system card. And originally it had the sentence in it that GPT 4.5 is not a frontier model. If you try to find this now, they've since edited the system card, so it doesn't say this anymore. But it's just such a funny thing for an AI lab to say, because at the same time, the model is really liked by people. And I think that one of the things that people caught on with this was doing green text, and they thought this model was very good at it. And since GPT 4.5, I think people kind of think that all the big models are kind of good at green text. So Claude 4 Opus and Gemini 2.5 Pro, people also do this now. And this is a sign that humor is really getting better at the models. And this is like a total viral moment where people like interacting with GPT 4.5. But if you look at the system card, it's like Sam Altman says we spent 10 times the compute as GPT-4 on it, and the evaluations are like a minor tick up. And when you look at reasoning models, all the reasoning models have like 20-point gains all the time. So it's this really odd release where I think this is a model that I still use very regularly in my day-to-day basis, but like it just can't land for some weird, complex reason of balancing this kind of vibes, eval scores, which are really important for marketing to both users and kind of business customers, because you get that first impression feeling, and then also price. And there's also these weird things where there's more people trying to get involved in these leading models, and the bar for releasing them is actually getting much higher. So these are two papers that are some of the, what I call like leading open reports on how to do reasoning model training. Open Thoughts 3 is on kind of data methods for instruction or supervised fine tuning, just kind of generating a large data set for performance on math and code. And Magistral is Mistral's first reasoning model. And the methods they describe are very strong, and it's very good for these companies to be open, and Bespoke Labs from Open Thoughts release the data as well. But it's like even these companies can get really bad press when the models just fail to do really simple things. So for example, the like open thinker model was the sort of model that'll think for minutes when you say hi to it. And the Mistral model is one of the models that every time you ask it a question will format it as if it's giving a math answer. And these are obviously like cherry-picked things from a known vocal critic because it is entertaining. But it's just like this is the space that AI operates in, which is like if you don't get the little things right, people are still going to complain and give you bad press, because the models that do things extremely well are just one click away. I think things like Claude 4 Opus is easy to use in there, and Gemini's coming, and there's more open models, and it's just hard to get a model out that has this kind of care to it, because it takes a lot of time and resources to kind of wait to release the model when you do all these kind of last bits of fine tuning. The most important one that's been in the news is kind of the sycophancy idea. This is not a real example from the model that they released for 2 weeks for ChatGPT. This whole little saga, I just imitated it by system prompting it, but it reads just like them, which is ChatGPT was unbelievably sycophantic for a few days. I'm not going to comment on all the kind of social second order effects because they're obvious, and that's a large motivation of why I do the work that I do, which is just like we want to be able to have understanding and oversight into things like that. But it reveals kind of deep organizational pressures that these companies are going through to kind of get things out the door fast that people really want. If you are to So here's some more examples. These are the GPT-4o version and one of these viral examples on what it was actually saying. And on the left is the Llama 4 secret chatbot arena version, which is the one they used to get the #1 score on Chatbot Arena, but never actually released. And talking to that was very odd, because on the release day, you're like, this can't be the model that they're saying is the best thing ever. It's just really strange. It's like the Llama example is like, I asked it what's its name, and it said a very direct and very good question. It's like, I don't think most people in this room want that answer, and that says a lot about evaluation and other things. But it's like, this is a deep-grained problem with reinforced learning from human feedback and collecting preferences, which is that if you're collecting preference data, you will give a multi-page document ranking your priorities on how you rate or compare the answers. And at the end, there's certain things like sycophancy that people actually just like to get out of the models, so they become tie breaks if they're particularly distinctive between the answers. And in the OpenAI post-mortem on Sycophancy, they had an extremely good breakdown on this. So I recommend that you read this, but I'll take a second and read out loud the core example. So they said, for example, the update introduced an additional reward signal based on user feedback, thumbs up and thumbs down data from ChatGPT. Throughout the post, they talk about how they trained a reward model to predict this. And with what we've seen from things like Chatbot Arena, it seems very likely that the strongest signal in that reward model was that it is just sycophancy is linked to these thumbs up data, and then that was expressed. And generally, this is a form of over-optimization. And the last line on this slide is something that's comes from a lot of history in the reinforcement learning literature, is that, for example, in sycophancy and that reward model, when they were training these models in post-training with many stages, so they go through some instruction tuning, and then they do RL, and they do RL, and they do RL. As you're really pushing the models to their limits, the strong optimizers that we use will extract performance where it's easiest in your training signals. And the easiest training signal is probably sycophancy, which is just like you add some emojis, you tell them they're good at it, and the models can pick up on that very easily. And then the decision-making problem that can explain most of these issues that we've talked about so far in the talk is that you have many evals, and these are things that you're trying to hill climb on, but you can never have all of them. So you're kind of doing a multi-objective problem, you're pushing all of those up, and it's often taking from something that you're not accounting for, and it's getting pulled way in the other direction. And this is where the things like art are important, and I'll kind of highlight a model that I think did this really well in a few slides. But I think as we see this competition for models, we'll both see more weird releases like this, where there's kind of rough edges. And there's also this much bigger opportunity in the AI space to release things that are really robust and bring a lot of joy and don't have these rough edges. So I think this kind of drive to be patient is going to be hard and hopefully rewarded when there's a lot of weird things out there. And for the non-researcher majority of this audience, the figure on the right is from what is like the original over-optimization paper in reward models. It's called Scaling Laws for Language Model or Reward Model Optimization. And this is just showing the x-axis is a technical measure that's KL distance, which is a distance that's used to reference the numerical change from a starting model to a final model when you're doing some RL fine-tuning. And this is showing that the y-axis, your reward model score, it goes up and then it goes down. So the hard part is when you don't have something you're confident in is you don't know when it starts going down in your over-optimization. So this is kind of a classic paper you'll see if you start digging into this direction more. And what I kind of want to highlight is that there's a Goldilocks zone between evals, vibes, and price. And I think particularly most models now are getting evals and price, and this middle one is hard. When I think about it, Claude 3.5 Sonnet was released over a year before Claude 4 Sonnet. And this model definitely had all of them. It was the one that got people in the Bay Area and here to switch from ChatGPT to Claude, and that it feels so ahead of its time because Claude 4 Sonnet really doesn't feel that different than 3.5, and it's definitely better, but these jumps are rare, and these models, it's like we're on this really fast slope, so if you get a really lucky model, you're just going to have such a really, really great output, and we'll kind of see where they come. I wouldn't know if I'd necessarily count O3 in this. It's like O3 is a proof of concept that you can do something, but it still has a lot of rough edges for people. And for example, it's like coding ability isn't quite good enough. But there will definitely be more of them, and it'll be kind of interesting to see what falls into that niche. And then kind of to transition into the art of modeling, and back to some of the stuff that I was presenting at the AI Engineered World Fair, and I'm thinking about for my day job is like, what comes next after we have this reasoning ability? And I've kind of come up with a few different things that people are going to be training into these models that kind of make some of these applications that I started with possible. So autonomy is a very discussed trend in AI right now. This is a plot from Meter, which is I think a nonprofit evaluation or monitoring startup, I think in Berkeley. And the plot here is the y-axis is the length of time that it would take for a human to do a task that an AI is now doing. And what we're seeing is that AI models over time are able to solve longer and longer tasks. It's important that I focus on this fact that it's a time of human task because I've messed up saying it in the past. And the TLDR is that climbing this is not free, and it takes a lot of hard work in improving the models and knowing where to push the models next to kind of unlock these. And it's like the reasoning paradigm is a good example because we couldn't keep hill climbing on what we were doing to kind of unlock this middle phase. So it takes a lot of effort, and kind of transitioning the focus from reasoning to things that are focused on planning and this kind of task abstraction is going to be the thing that unlock these next models or even systems. I think you might see like a deep research bullet point on here rather than like O4 being on here. And then the question is like, how do we actually do this in a model, and how do we train autonomous models? So when I think about traits of these kind of independent agent models, I think about starting with skills, which is what I talked about with reasoning, and then kind of expanding into other traits that are going to be needed. So I kind of think of calibration, which is models that know what they don't know, and I think that labs haven't been using this because it's been easier to unlock performance by just building skills than having the models being kind of introspective. They just haven't needed it because they're not doing a lot of tasks on their own, and the humans could give the feedback. And then to kind of go with this, there's a few, what I described these last two as two different subsections of planning. Is trying not to overburden the term because strategy is kind of like creating a plan in itself and knowing where to go. So if you ask DeepSeek R1 a very hard math question, it won't first plan. It'll just dive in and start to try to solve it. And having the model spend the time to refine its direction before solving it would be very important. And then when we're doing things like deep research or hard coding problems, we need a model that if it's presented with a plan, knows how to do itself and like certain inference passes to solve subsets of it or to dispatch that to other agents that can kind of take these steps on the problem and actually solve them. These are things that their models aren't trained to do at all right now, where it's like skills we have, inference time scaling, the basic RL stuff has unlocked this. I don't think we need that much, like the models are solving almost impossible math questions for mathematicians. Like we don't need to push it that much further. And calibration, there's a lot of research on that. And then these last two is like what I think is like the next Q-star like thing where there's going to be a lot of human data, and then we're going to have a few good examples that we can then use to iterate with more complex training. And so if we like revisit this example to ground my taxonomy, I call this very skillful but lacking planning. So search is a skill that O3 has largely mastered. It can find really niche information, but if we're going to pair this to deep research, like it doesn't quite know how to compare and contrast and know how much information it needs to gather before making its conclusion. So planning and synthesis is something that we have to encourage the models to do more of before we kind of just, to unlock the next phase of progress. And to end, this is a somewhat technical provocation, but is something that I hear is definitely happening directionally on the ground of other labs, is like this RL and post-training is becoming the focal point of language model development. It doesn't mean, like pre-training is definitely not dead now, but mathematically in terms of compute, these techniques for reasoning and planning are really becoming the bedrock of what people spend their money on. So this is a plan that it's like, people ask me like, what am I doing at AI2 to try to make a better reasoning model? And like at the end of the day, the technical things are not that complicated, which is you get a big data set, you filter the data set, you train the model for a while, and then after you have your models, you do a bunch of the things that are in all the research papers. So they have a few ideas, and you try them at the end, and they might give you like 1%. This is mostly suited for a technical audience, but fun to include. And then back to this like from post-training to training idea, it's like how do we integrate this compute where post-training is similar in GPU hours? And then there's the idea of like continual learning, and if we don't ever have to really pre-train a model at all, and we can kind of just keep using these real-world interactions to provide signal to the model. If we ground it into some real numbers, DeepSeek v3 was the famous paper that kickstarted a lot of discussions on like how much does it cost to train a frontier model, and they listed these prices at $5 million. Within that table, they said that post-training used like well less than 1% of the compute. A fun example is that a researcher on their RL team tweeted that DeepSeek R1 trained for a, quote, few weeks in the RL stage. This is obviously not something that you want to base any sort of like investment or strategy decision in. But if you extrapolate from the tweet, it's like DeepSeek R1 could be like 10 to 20% in GPU hours. If you talk to somebody at OpenAI, they'll also say similar things, which is like O1 uses very low percentage, but O3 was 10x the RL compute, and O4 should be the same, which is that this post-training phase is already becoming 10 to 20% of the compute used for these larger models, and that's where people are looking to push limits with these things like planning and so on. So it should be fun. This means that we'll get model releases more frequently because you can kind of see where the performance is going during these RL runs, where pre-training you have to wait all the way to the end for technical reasons to see how the model is doing. So for people building models, I think these next 18 months are going to continue to feel like what it has in the first 6 months of the year, where it's every few weeks we're getting something that is potentially noticeably better. So that's where I've ended. I'm probably a little under on time, but potentially catching up for break time. So thank you all for listening.
We have time for a few questions. Okay, good questions. I saw your hand first.
Great talk, Nathan. In terms of the planning research, I'm curious, like, how do you see the neurosymbolic research and approaches fitting in? Because one approach is that you're learning, like, how to do planning based on reasoning traces or training. Another approach is that you actually design your specifications and primitives and programming language within which you express your solution, so you constrain the search space, right? Alpha geometry being an example of that. So I'm curious how you're thinking, because a lot of these kind of predictions are based on transformers with post-training and RL, but if you have other architectures, that might change.
I would say that I see a path for what people are doing with transformers, and that is like because these models are good at generating plans if prompted to do so, so that's a kickstart. And I think in many ways I'm like practical in this regard, which is I expect that to be the path that we're going down. And then it's like the stupid answer, which is, as a researcher, I'm like, at some time in the next 2 to 50 years, there's going to be something that bumps us out of transformers. And mostly because I'm so unversed in neural symbolic programming. I was like, I barely even know. I was like, oh gosh, I don't even know how to answer this question because I don't know what it means. And that's like, I think realistically, that's what I expect. I'm happy to discuss more if you have better examples for me.
All right, I saw a question over there.
Yeah, that was my corollary question, is what have you seen in the planning and abstraction paper space? Are there any papers you would recommend or you think that are going to be fruitful to what's capturing your imagination? Yeah.
I don't know if I have slides on this, but I've written about this, which I think that a big thing in the academic space that's blocking research here is that experimentation is so expensive. So if you estimate deep research, it does like 1 million tokens per inference. That's anywhere from a few dollars to a few tens of dollars per run in public price of compute. So a lot of those things are just like, we barely have the open models to do research that are at the capability, and then the cost is really high if that's like one inference run in an experiment. So that's something that I'm worried about in a way, but I think you can break down the problem a bit better. And I don't have them off the top of my head. There's a lot of research on like using search, but it's more on the kind of RAG level. But I just think that a lot of it is going to be finding very hard problems that they can hill climb on. Because it's hard to make a planning benchmark, which is like it's like going to be LLM as a judge and not that reliable. But I think it's going to be like hard tasks that people figure out how to get 10 to 20% on, and then planning is a way that they help the models get better at it, and it should come from there.
All right. So Nathan will be around later. We have 2 panels. So the second panel for what's next, Nathan will actually be there on, and so we can continue answering questions there. Does that work for everyone? All right, one more round of applause for Nathan.